The next thing that we're going to do is we are going to build out this receive new block endpoint that we are using in our mine endpoint. And actually, I spelled this wrong, so I'm going to correct that right now. It should be RECEIVE, receive new block. Cool. So we are going to build out this endpoint right now. So I'm going to copy this, and I'm going to come down here, and let's say app.post to receive new block. And it's going to take in a callback function that takes in the request, the response. Cool. So inside of this endpoint, we are expecting to receive a new block that's being broadcast. So let's save that new block by saying const new block equals rec.body.new block, because we are sending in the new block on the rec.body.new block property. Cool. So when all of our other nodes receive this block, they want to check a couple of things to make sure that this block is legitimate and it's actually a real block and that it fits into the chain properly. So the first thing that we want to do is we want to check if the previous block hash on our new block is equal to the hash on the last block in our chain. So let's do that now. So in order to do this, we're going to need access to the last block in our chain. So we are going to say const last block equals bitcoin.get last block. Cool. And now we are going to test if the last block dot hash, or in other words, if the hash of the last block is equal to the new block dot previous block hash. So basically, inside of our new block, the property that says previous block hash should be equal to the hash of our last block in our chain. That way, we know that this new block does indeed come right after the last block in our chain. So this statement is going to return true or false to us. We hope that it returns true because that would mean that this new block is legitimate. So let's save this true or false value in a variable by saying const correct hash equals the result of this comparison right here. Cool, so that's one check that we have in place now. We are checking to see if the hashes line up properly with the new block and the last block in our chain. One more check that we want to do is we want to make sure that the new block has the correct index, which means that the new block should be one index above the last block in our chain. So we will say const correct index equals last block at the index property plus 1 equals our new block at the index property. Cool. So now we are checking to make sure that our new block has the correct index, which should be one index above our last block, which makes sense, right? It's the next block in the chain. Cool. So now we want to take two different actions depending on whether or not this new block is legitimate. If this new block is legitimate, we want to accept it and add it to our chain. If it is not legitimate, we simply want to reject it. So in order to do that, we are going to use an if-else statement. So we will say if correct hash and correct index, meaning that this block is in fact legitimate, So if it has the correct hash and the correct index, we want to add it to our chain on this node by saying bitcoin.chain.push the new block. And since we just added a new block to our chain, that means that we have to clear out our pending transactions, because our pending transactions are now inside of this new block. They were put into this new block when it was mined. So we're going to say bitcoin.pending transactions equals an empty array. Cool. And the final thing that we want to do is send a response back that says we accept this block and we have added it to our chain. So we will say res.json, an object, and this object will have a note that simply says new block received and accepted. And we will say that the new block is equal to the new block. And we'll just send that back as well. Cool. So if the new block is legitimate, then this is what we're going to do. We're going to add it to our chain, clear out our pending transactions, and send back a response that says everything worked perfectly. But if the new block is not legitimate, we are going to do something else. And we're going to do that inside of this else block. So if the new block is not legitimate and both of these tests do not pass, then all we're going to do is send back a response that says the block was rejected. So we'll simply say res.json, and we'll send back this object that has a note on it that says new block rejected. And we will send back the new block that was rejected. Cool. And that's it for our receive new block endpoint. So let's run through it top to bottom again real quick, just to make sure we understand what's going on. So inside of this receive new block endpoint, we are receiving a new block from a broadcast that's taking place. We are expected to add this new block to our blockchain. But first, we want to do a couple of checks to make sure that this block is legitimate. So we check to make sure that it has the correct hashes on it, and we check to make sure that it has the correct index. If it does have both of these things correct, then we add it to the new chain, and we clear out the pending transactions. And then we simply send a response that says the new block was received and it was accepted. And that's it. But if both of our checks do not pass, which means our new block is not legitimate, then we don't add it to our chain. We simply send back a response that says the new block was rejected because it's not legitimate and we don't want it to be a part of our chain. And that's it. That's how our receive new block endpoint works. In the next video, we will be testing both our receive new block endpoints and our mine endpoint to make sure that they work correctly and to really understand a little bit better just exactly how they are working. I'll see you in the next video.